I would share a vision of the future inspired by my recent experience, where we developed a new process for potash, production from alternative potassium sources. And we did that in particular in the context of Brazil, which is a country which doesn't have existing supply, national supply of potash. And then my other view of my other resource to see the future is related to aluminum, where again aluminum recycling doesn't work very well today because we have impurities coming back from the aluminum recycled products, and those impurities, we don't have good technologies to separate them, which means at the end we are downgrading the quality of the aluminum as we are recycling it. So on one side, the example of alternative potash for a huge agricultural country like Brazil. On the other side, the new approach that we have developed for aluminum recycling give me a better appreciation of how the future could look like. It is quite clear that the future will be very regional and very much integrated. What I mean by integrated is that regions where we would need more fertilizer for farming, or where we will need more aluminum to make modern products, will also be regions that will need to have energy production. And that energy production will have to be carbon free. And invariably, this leads to electrification, but an electrification that is a little bit different than what we have lived so far. It might be a very regional electrification. Maybe it's going to be an intermittent generation of electricity. In the sad event of a natural disaster, we could see entire regions where there used to be manufacturing unable to provide the aluminum raw material, the potash raw material, or the copper. We have experienced that actually in the recent pandemic, where the supply chain has been completely broken. And even nowadays, as I speak, many manufacturing corporations have a difficulty getting their supply on certain materials. So I think this notion of intermittency of energy generation, possibly intermittency in the logistic, really calls for the type of processes that we are developing. These are processes that are resilient to stop. That is to say, the notion that you need 1 million tons per year, 24 hours a day, 365 days per year, in order to be cost effective, means that there are some issues with the way we use energy, with our ability to store and use energy where we need it. And some of the processes that we are thinking about integrate that notion of intermittency. In particular, when we go to the high temperature processes, we have the ability to provide heat at high temperature. We have the ability sometimes to have a byproduct that can be converted again to electricity. So here I'm describing a future where a plant would be there primarily to make the metal product that it's intended for, let's say a copper production plant. But when times are difficult, when there is no more sun, when the logistic is broken, that same plant has all the resources and the cost effectiveness to bring back to the community around the plant energy, materials, maybe sometimes chemicals or heat that would basically contribute to the local development and the local sustainability. I really believe we need to provide materials processes that are fully integrated with what the local and regional communities are asking for. And that calls for breakthrough in our processes, as well as courage and dedication of the metals and minerals industry.